Hey class, Mr. Houston here, and today we're talking about the last section in chapter 2. And today's lesson is all about proving angle pair relationships. So we're going to look at a pair of angles or two angles, and we're going to prove what kind of relationship that they have. All right, so the first theorem we are talking about, or that we have here, is the theorem 2.3, and that is the right angle congruence theorem. Basically, all it states is that all right angles are congruent, which hopefully you knew because all right angles are 90 degrees, therefore they are all congruent. All right, so let's kind of put that into use or show how it works. In example number 1, using the right angle congruence, we're going to write a proof proving that angle B is congruent to angle C. Okay, so we are given that AB is perpendicular to BC and DC to BC. Notice as we keep talking about proofs, this statement is also right here. And so our main reason for number 1 is just simply that they give us that information. It is the given. All right, next thing we say is that angle B and angle C are right angles. And we know that because of this little mark right here. We've talked a little bit about that, but that little mark, the little upside down T, means perpendicular to. All right, so anytime we know that something is perpendicular, we know that it intersects at a 90-degree angle. Okay, so B and C are right angles, and so the definition of perpendicular lines is what would tell us that B and C are right angles because they are perpendicular, they intersect at a 90-degree angle. That's why B and C are 90 degrees or are right angles. And then we know that B is congruent to C through the right angle congruence theorem. So basically that theorem we just talked about up top came into play here because we have this right angle and this right angle. They are obviously going to be congruent, and we just proved how. So again, proofs are just a logical step through of proving something that maybe you already know or maybe you don't know, but we have to prove it using theorems and postulates that we know. All right. So theorem 2.4 and 2.5 are congruent supplements and congruent complements theorem. These are somewhat similar to the transitive property. And if you don't remember what the transitive property is, that is if A equals B and B equals C, then A equals C. So we kind of cut out the middle person to make another statement. And that's kind of what we talk about here. So for the congruent supplements, if two angles are supplementary to the same angle, so in this case they're talking about 1 and 2 are supplementary and 3 and 2 are supplementary. If that is the case, then 1 has to be congruent to 3. So just to put some numbers with this, say angle 1 was 35 degrees. In order for 2 to be its supplement, that would have to be 180 minus 35, so this would be 145. And then in order for 2 and 3 to be supplementary, angle 3 would have to be 35. So notice 1 and 3 are the same because they're both supplements to angle 2. So again, the transitive property. So 1 and 2 are supplementary, 2 and 3 are supplementary, so 1 is congruent to 3. And the same goes for complements, except this one, instead of 180 degrees, now this is 90 degrees. So if 4 is complements to 5 and 5 to 6, then 4 and 6 should be congruent to each other. Okay? So let's kind of put those into use. Taking a look here at the back of your worksheet. We're going to prove that two angles are supplementary to the same, or we're going to prove that two angles supplementary to the same angle are congruent. So we're going to prove the theorem that we just talked about on the previous page. All right, so let's take a look at our statements. Angle 1 and angle 2 are supplements. Angle 3 and angle 2 are supplements. Again, it's the same thing that's right up here and it's listed under the given. So the reasons for that one is the given. Okay, next for 2, we said that 1 and 2 are supplements. So we say that the measure of angle 1 plus the measure of angle 2 is 180. 3 and 2 are supplements. So then we say that measure of angle 3 plus the measure of angle 2 is equal to 180. That's just the definition of supplementary angles. We know that supplementary angles are 2 angles that add together to make 180 degrees. So because we now say their measures add together to equal 180, that's just simply the definition. Number 3, measure of angle 1 plus measure of angle 2 equals the measure of angle 3 plus the measure of angle 2. Might be a little harder to see this, but notice how we have measure of angle 1 plus measure of angle 2, and then equals 180, and then we have the measure of angle 2 plus the measure of angle 3. Notice how what we kind of did here is we took what those 2 statements had in common and we crossed them out. So we used the transitive property. It just doesn't look like it normally does, but we use the transitive property of equality. Now, usually you would have seen, or you used to would have seen it written as 180 equals the measure of angle 3 plus the measure of angle 2. But anytime you have a statement like this, and they both equal kind of the same thing, you can cross those out and set them equal to each other. Okay, and then looking at step 3 to step 4, we subtracted the measure of angle 2 from both sides. So in order to do that, we use the subtraction property of equality. And angle 1 is congruent to angle 3 by the definition of congruent angles. Now you're asking why the definition of congruent angles. We know that congruent angles have the same measure. So notice how we went from the measure of angle 1 down to just angle 1. When you do that, it's usually a definition of some sort. In this case, it's the definition of congruent angles. And so there we proved that 1 and 3 are congruent and that they are supplements to angle 2. All right, last 2 postulates and theorems here. Linear pair. If 2 angles form a linear pair, they are supplementary. That we already kind of know because it's kind of in the name, the line, so it's going to equal 180. And then vertical angles congruence theorem, something we haven't talked about yet, but remember, vertical angles are angles formed when you have 2 intersecting lines. So 2 and 4 are vertical angles, and 1 and 3 are vertical angles. What we haven't talked about yet is now vertical angles are congruent. So when they're across from each other, like 1 and 3 are congruent, and 2 and 4 are congruent. Okay? So we're going to prove the vertical angles congruence theorem through this proof right here. All right? So 5 and 7 are vertical angles. We are simply given that information. Okay? That is right up at the top. It is given. 5 and 7 are vertical. We're going to prove that they are actually congruent. All right? So 5 and 6 are a linear pair. So if we look up here, 5 and 6 are a linear pair. And we also say that 6 and 7 are a linear pair. So when we look at that, really, that's just the definition of a linear pair. There's no numbers involved. So we simply just have to say that it's the definition of linear pair because they are 2 angles next to each other that add together to make 180 degrees or make a straight line. Number 3, 5 and 6 are supplementary. 6 and 7 are supplementary. And we know that because we know this part right here, a linear pair. I'm going to briefly go back up here. The linear pair postulate says that 2 angles that form a linear pair then are supplementary. So we can make that jump from a linear pair to supplementary by the linear pair postulate. And then we have 5 and 6 are supplementary, and then we have 6 and 7 are supplementary. They have the 6 in common, so we can take those out. And we found that 5 is congruent to 7. That's from the previous page when we talked about congruent supplements. So if we have two angles that are supplements to the same angle, then they have to be congruent. So it's the congruent supplements theorem. And that's basically how it works. A theorem for the most part, or I'm sorry, a proof for the most part, is you're proving, like we're proving this, but we're doing it without any numbers. There's no angle measurements involved. I could simply say, well, this is 35 degrees, and then you from there could figure out the rest. You could say, okay, so if angle 5 is 35, angle 6 has to be 145 because it's going to be 180 minus 35. And then I know that if angle 6 is 145, then to figure out angle 7, I'm doing 180 minus 45 again. I'm going to get 35. So look, 5 and 7 are congruent. So we can do it through numbers, but a proof is trying to do it through words and with postulates, theorems, and all that kind of stuff. All right, so that's the end of chapter 2. If you have any questions, bring them with you to class, and we will see you then.